Lesson 866, Interpreting Slopes, the slope of a fitted line. In this lesson, we'll describe whether data in a scatter plot has a positive association, a negative association, or neither. We'll also interpret the slope of a line to fit data in context. Let's turn to page 81. We've been talking about scatter plots for a few lessons now, or actually lines of fit for a few lessons now. So we're going to bring it home a little bit more as we talk about the slope of a line today. Now, 2 learning targets. First of all, we're going to explain whether data in a scatter plot it can be any of 3 things. There can be a positive association shown in the data, a negative association, or it could be that there's no association at all. And that's going to be determined by the direction of that fitted line. And secondly, we're going to interpret the slope of a line of fit. In a real-world situation. Now, when it comes time to interpret the slope, it's hard to know what to say sometimes to explain what the slope means. So much as I love your creativity, I'm going to give you a script that's going to help us to say what we mean to say. We'll come back to this script in just a moment, but I'm going to write it in red so that it stands out when it comes time to make a note card for the test. The first part of the script is going to be about the x values and what x means on a graph. So this is going to be a fill in the blank. So when blank, where blank is whatever x represents, like foot length here in this graph. When foot length or blank increases by 1 unit, this number is always going to be 1. And this is whatever the unit of measure is. In this case, it would be centimeters. So that's what we're going to say about x. When the foot length increases by 1 centimeter, when x increases by 1 unit, and now we're going to switch to talking about y. Whatever y represents, in this case, the foot width, the next word is you're going to have to choose whether it's increases or decreases. And you'll have to look at the data to decide which word to use. So the foot width increases by, and this is where the number of the slope goes, whatever number you have. You've made a slope triangle, you've figured out the slope, that's where that number goes. And then the units for that y value. So if I were going to interpret the slope of this, I would say when foot length increases by 1 centimeter, foot width increases by, and let's say the slope is 0.3 centimeters. 0.3 centimeters. So that's how that's going to go. We'll come back to this soon, but it's a handy little script for interpreting the slope once we find it. All right, let's move on with the other things that these notes have to say. Sometimes we want to know how 2 variables are related. In this case, we can use the slope of a linear model to explain how increasing one variable typically changes the other. So here's a scatter plot of foot length and foot width for a bunch of different people. Each dot represents a person and the 2 measurements we've taken from that person. And we can see that as the foot length increases, the foot width tends to increase as well. So when both things increase together, this means that there is a positive association. I'm going to cross off these other two. There's a positive association between foot length and foot width. Okay. A negative association would mean that as one thing increases, the other thing decreases. And we saw that in the activity today when we looked at the weight of a dog and its life expectancy. The weight increased, the life expectancy decreased. And here's that script from above that I was talking about. They've already kind of written this for you, but we'll get a chance to use this down below in a minute. So they're interpreting the slope. The slope of the fitted line is about 0.32. Now we're going to need this information in order to interpret it. Here we go. When the length of a foot increases by 1, always starts with that 1. When the foot length increases by 1, the model predicts that the width will increase, circle increase here, that's the word I have to choose, by, now we're just told the slope is 0.32, so that number goes here, and the unit of measure. So that's interpreting the slope. If the length of a foot increases by 1 centimeter, the model predicts that its width will increase by 0.32 centimeters. Let's try that again with another graph. This one showed an increasing or a positive association. This next one's going to show us a negative association. So here's data on the weight of 21 cars. There's 21 little dots on this scatter plot. 21 cars and their fuel efficiency. Fuel efficiency is just how many miles are driven on each gallon of gas. So we're asked to meet both of our learning targets. Explain whether the data has a positive, negative, or no association, and then also interpret the slope. So let's do the easy one first. First of all, describe the relationship between the weight and the fuel efficiency. Well, I can see that as the weight is increasing, the actual fuel efficiency is going down. The more a car weighs, the more I don't know how to say it right. I'm not even going to try to say it right now. I'll say it when I come down here. So the relationship, it's a negative association. Which means as one variable increases, the other one decreases. As the weight goes up, the fuel efficiency decreases. So the variables are moving in opposite directions. That's what makes it a negative association. And here's the other part where we're going to do some interpreting. And we're given the slope again. It's always helpful when we don't have to find it ourselves. If we're asked what does the number mean for the weight of a car and its predicted fuel efficiency, we're going to be interpreting here. So I don't know if I can get both things on screen at the same time. Way at the top of the screen, there's my script. So I'm going to be filling in these blanks to interpret what this slope of -10 is telling me. So let's start it off. I'm going to start with the word when. I'm going to talk about the x stuff a little bit. When it says x up here, so I'm going to say weight. When the weight increases by 1, it's always 1 for that first number. 1, and then we're asked for the unit of measure on these x values. This is measured in tons. When weight increases by 1 ton, comma, now we're going to switch to talking about y. That's about fuel efficiency in miles per gallon. Okay, so I'm going to say the fuel efficiency, that's what y represents, fuel efficiency, I have to choose increases or decreases. Our fuel efficiency is decreasing. Fuel efficiency decreases by, now I know the slope is -10, but I'm going to say 10 miles per gallon. And the reason I'm saying 10 instead of -10 is because the word decreases already kind of takes the place of that negative sign. Fuel efficiency goes down by 10 miles per gallon. So I don't need to write the negative there. That'd be like a double negative and it'd be awkward. So there's the interpretation of that slope. When weight increases by 1 ton, fuel efficiency decreases by 10 miles per gallon. All right. So let's finish up with being clear on what positive, negative, and no association mean. We've seen one example of each here. This had a positive association. Foot length increased as foot width increased. And we've seen a negative association as weight increased, fuel efficiency decreased. Let's just nail this down a little bit better. I think you have the words positive association, negative association, and no association here at the bottom. Mine got cut off. So I'm just going to draw a quick little scatter plot that has a positive association. That line of fit would have a positive slope. As one variable increases, so does the other. Do the same thing with a negative association. Make a little scatter plot again, just to demonstrate what a negative association would look like. Sorry, I meant to do those in blue. Here's my line of fit in red. Oh, it's a terrible line of fit. It does not pass through the middle of the data, but I can see that it has a negative slope. So as one variable increases, the other variable decreases. And then the final one is when there's no association, when there's no clear pattern or trend. One more time, let's make a fictional scatter plot. So I'd have a hard time fitting a line to this because there's no clear pattern or trend. Right, so that's us analyzing these lines of fit and their slopes today. It might have a positive association, a negative association, or no association. And we can use this script to interpret what the number in that slope means.